Beyond the furthest reaches of our most powerful telescopes, there exists a world where the Tyrannosaurus rex still hunts, and the skies are darkened by the leathery wings of pterosaurs. This isn't a forgotten valley on Earth or a Jurassic Park gone wild. This is an entire planet thriving with the titans that vanished from our own world 66 million years ago. Imagine, for a moment, that we finally found it, a living, breathing dinosaur planet. On Earth, their reign ended abruptly. A colossal asteroid, perhaps combined with intense volcanic activity, plunged our world into an ecological winter. Dust and ash choked the skies, sunlight vanished, and the great photosynthesis engines of the planet stalled. Food chains collapsed from the bottom up, and the giants that had dominated for over 160 million years simply couldn't adapt. Only their distant descendants, birds, survived the cataclysm, along with a few smaller, hardier mammals, ancestors to nearly everything walking the Earth today. Our planet, in essence, hit a cosmic reset button, giving rise to an entirely new era of life. But what if, out there in the immense cosmic ocean, another planet, a carbon copy or a close cousin, never experienced that calamitous impact? What if its geological clock ticked differently, or its solar system offered it a shielded existence, allowing those ancient lineages to not just survive, but to continue their grand evolutionary story? The first hint of such a world wouldn't be a roaring T-Rex in a telescope, but rather a subtle anomaly in the atmospheric data from a distant exoplanet. Our advanced observatories, tirelessly scanning the light from other stars, might pick up an unusual atmospheric signature, perhaps a significantly higher oxygen content than we'd expect for a planet of its age, or a peculiar mix of biosignatures hinting at a very different kind of biosphere. The spectral analysis, a cosmic fingerprint, could show patterns that don't match anything we've categorized from microbial life or modern complex ecosystems. We'd see traces of methane, oxygen, and other gases in ratios that scream life, but life unlike the familiar greens and blues of Earth. The initial discovery would be a whisper, a statistical blip, sending shockwaves through the scientific community. Years of painstaking verification using ever more powerful telescopes would follow. Teams of astronomers, planetary scientists, and astrobiologists would pore over every photon, every data point, searching for confirmation. The excitement would be palpable, a quiet hum before the storm of public announcement. Then, the first actual images. Not blurry blobs, but perhaps with next-generation interferometry, the resolution to discern large, moving shadows on the surface beneath swirling cloud patterns. Imagine the raw, unfiltered awe, the spine-tingling realization as scientific models interpreting these shadows confirm colossal forms. Shapes that couldn't be anything but the multi-ton behemoths we only know from fossils and reconstructions. A long neck stretching hundreds of feet across what looks like a primordial swamp. A massive bipedal predator striding through dense alien forests. The moment the images are confirmed, the world would collectively gasp. It would be an event that transcends science, politics, and culture. Every news channel, every social media feed would erupt. Humanity, for the first time, would be looking upon a living, breathing past that never ended. The planet itself would likely be a vibrant, volatile world. To sustain such immense creatures, it would need a denser atmosphere, perhaps with higher oxygen levels than Earth's present 21%. This abundance of oxygen would fuel higher metabolic rates, allowing for greater growth and supporting the sheer biological machinery needed for truly gargantuan organisms. The climate might be globally warmer and more humid, a greenhouse Earth much like the Mesozoic era on our own planet. Vast, shallow seas could dominate, providing nutrient-rich environments for marine reptiles. The land masses would be covered not by familiar grasslands and flowering trees, but by immense forests of cycads, ferns, ginkgos, and towering conifers. Imagine entire continents covered in dense, dark green foliage, punctuated by colossal trees unlike anything alive on Earth today, providing endless food for the largest herbivores. Active geology would be common, perhaps fewer devastating asteroid impacts, but still the grinding, creative force of plate tectonics, constantly reshaping continents and fueling volcanoes, enriching the soil with minerals and creating new habitats. The dinosaurs on this alien world wouldn't be exact replicas of their Earth counterparts. Evolution, even with similar starting conditions, diverges over tens of millions of years. We might find species that bear a striking resemblance to a Triceratops or a Brachiosaurus, a testament to convergent evolution, where similar environmental pressures lead to similar forms. But we'd also undoubtedly discover entirely new families, new genera, creatures that never arose on Earth or took radically different paths. Perhaps theropods evolved even greater intelligence, developing complex social structures and communication methods we can barely fathom. Maybe sauropods grew to even more impossible sizes, supported by the planet's potentially lower gravity or an even more robust skeletal structure. But we'd also undoubtedly discover entirely new families, new genera, creatures that never arose on Earth or took radically different paths. Perhaps theropods evolved even greater intelligence, developing complex social structures and communication methods we can barely fathom. Maybe sauropods grew to even more impossible sizes, supported by the planet's potentially lower gravity or an even more robust skeletal structure. Picture an apex predator, a theropod far larger than T-Rex, its hide covered in iridescent scales, or a feathered giant with wingspans that dwarf our largest aircraft soaring through an alien sky. The sheer diversity would be staggering, a living textbook of evolutionary possibility. The implications for human exploration would be immense and terrifying. A mission to such a world would be humanity's most ambitious undertaking, dwarfing the Apollo program. We wouldn't just send a simple probe, we'd be planning for a reconnaissance mission, followed by increasingly sophisticated efforts. The journey itself would take decades, even centuries, using technologies we have yet to perfect, like advanced propulsion systems or generational starships. Upon arrival, the initial orbiters would meticulously map every inch of the planet, analyzing its atmosphere, geology, and most crucially, its dominant life forms. We would be looking for signs of intelligent behavior, but also for areas that might offer a foothold, a safe landing zone, if such a thing exists. The concept of a prime directive, a non-interference policy, would become a global debate. Do we observe from afar, protecting this natural wonder? Or does the insatiable human drive for knowledge compel us to get closer, to understand this living fossil record of a bygone era? The dangers would be unimaginable. Landing on a planet dominated by multi-ton predators would be like setting up camp in the middle of a lion pride's territory if the lions were 10 times bigger and had jaws that could crush steel. Any landing craft would need to be an armored fortress equipped with defensive capabilities beyond anything we currently possess. Every step outside would be a calculated risk. The very air we breathe, while potentially richer in oxygen, might harbor alien pathogens against which we have no immunity. The flora, while visually stunning, could be toxic, its pollen a deadly allergen. We wouldn't be going to a sterile moon, but to a hyper-alive world where every leaf, every rustle in the undergrowth could signal a threat. Our presence, however carefully managed, would itself be an intrusion. The ethical questions would multiply. Could we accidentally introduce Earth microbes, potentially devastating this ancient ecosystem? What if the dinosaurs themselves proved to be more intelligent, more aware than we initially assumed? The societal impact on Earth would be profound and multifaceted. Entire economies would shift to support the monumental effort of studying this new world. New scientific fields would explode, dedicated to xenopaleontology and astrobiological ecology. Art, literature, and philosophy would grapple with the implications. Are we truly unique in the universe, or is life's pathway far more common than we believed? Does this change our understanding of our own evolution, our own place in the grand cosmic narrative? Religions might find their doctrines challenged or reinforced, depending on their interpretations of this discovery. The sheer wonder and terror would permeate every aspect of human existence. Imagine children growing up with images of actual living dinosaurs, not just museum skeletons. Imagine the debates about whether we should ever attempt to bring DNA back, or if we should leave this ancient epoch untouched, a natural preserve on a cosmic scale. Ultimately, the discovery of a planet where dinosaurs still exist would be humanity's greatest revelation, a looking glass into a past that somehow continued. It would force us to confront not just the sheer vastness and diversity of life in the cosmos, but also our own fragile place within it. We would gaze upon a living legacy of Earth's own geological youth, a testament to what might have been. It would be a mirror reflecting our planet's earliest chapters, demonstrating that even the most catastrophic events can be mere footnotes on a different world. The dinosaur planet would be a monument to evolution's infinite creativity and a humbling reminder of our brief yet significant moment in the sun.